In this class, now I am going to explain you a problem from probability. This was given in JEE Advanced 2023 paper 2, and see that question. A coin is thrown repeatedly until we get two successive outcomes as same, and also given that probability of getting head is 1 by 3. Then find probability that experiment ends with a head. Okay, once again I repeat this question, listen carefully. A coin is thrown repeatedly until we get two successive outcomes as same, and the probability of getting head is 1 by 3. Then what is the probability that experiment ends with a head? This is the question. Very easy. See, observe me how I am going to answer to this question. See, as per the given data, that successive outcomes must be same, they mentioned in the problem, so that we people have to throw the coin more than once, not at one time. It has to be thrown more than one time. Means we may throw twice or thrice or 4 times or more than that. Okay? See, let us consider E be the event which is favorable to us. Means getting head at the end of the experiment. Getting head at the end of an experiment. Yes. Next, see, that coin we may throw twice or thrice or 4 times or more than that, no? So first I would like to consider E1 is a set which contains set of outcomes thrown even number of times, and E2 be one more set which contains outcomes of that random experiment when we throw odd number of times. Okay, so now come to this set. I am throwing even number of times, means here twice I have thrown, so outcomes, successive outcomes is same and ending with head. Next, HT, HH. Now successive outcomes is same, ending with H. 4 times I have thrown, first time, second trial, third, fourth trial, like HT, HT, HH, 6 times, 6 trials. So successive outcomes is same, ending with H, and so on. This is favorable to us. And throw odd number of times, we may get like this, THH. First tail, 2 times heads, and tail head, head 5 times, odd, tail head, head. Next, tail head, head 7 times, and so on. Okay, both are subset of our required event. E1 is subset of E, and E2 is also subset of E. We people have to determine probability of an event E. So here E is the union of E1 and E2. Observe, both are disjoint sets. So in such case, P of E should be written as P of E1 plus P of E2. Okay, so now prepare these two individually, and after getting the P of E1 and P of E2, substitute here. Then your problem will be done. Okay, see here. Now find probability of an event P of E1. So you know this is first trial, this is second trial. This is happened after occurrence of these two. This. So which means that both are independent events. In the case of independent events, what you have tried both of them? So this is, so P of H into P of H whole square. P of H whole square. You know, in the case of independent events, we write that multiplication theorem as P of A into P of B. So here 4 times, all are independent. No one is depending on the previous trial. Hence, okay, what you have to do? That multiplication theorem. Apply that multiplication theorem over here. So that you will get here P of H into P of T into P of H into P of H. 3 H's we are getting. Hence, P of H whole cube into P of T. Now go to third one. Here 4 heads, 2 tails. So 4 heads whole cube and P of T whole square. This process will continue. Okay. Now simplify that. If you simplify, what do you get? So from all of them, what do we take common? Otherwise directly you can write. It is here. This by this. You will get P of H cube into, see if you divide this with this, what do you get? P of H into P of T. Here also if you divide this with this, P of, see students, when you divide this with this, so here it is even number of times, no? I think here you will get, see here twice, this is 4 times, this is 6 times. So here TH, TH, HH, TH, TH, HH means here H is getting 4 times. So write here 4. T is twice. P of T whole square. This is correct. Now when you divide, okay, this with this, you get P of H into P of T. When you divide this with this, P of H into P of T means here it is forming a geometric progression, infinite geometric progression. Their number of terms are infinite. Hence here we have to apply sum of infinite terms of GP. So you know that formula, A by 1 minus R. Here A value P of H whole square by 1 minus R, term 2 by term 1. So what do you get? P of H into P of T. So you know P of H, probability of getting head is given as 1 by 3. Here whole square is there, 1 by 9. 1 minus P of H is 1 by 3. If P of H is 1 by 3, obviously P of T is 2 by 3 will come. You know that. Both are complementary events. So that if P of H is 1 by 3, P of T is 2 by 3. Now simplify that. If you simplify, what do you get? See here. Cross multiply. 9 minus 2, 7. Okay, 7 by 9. 9, 9 cancel. So you get 1 by 7. Now go to the second set, P of E2. So here how many heads? 2 heads, 1 tail. So P of T into P of H whole square. And here 2 heads, 3 tails. Now P of T whole square, P of H whole cube. Now here 1, 2, 3, 4, 5, 6, 7. So 4 heads, 3 tails. P of T whole cube and P of H whole power 4 and so on. Now observe the students. Again it is forming a geometric progression with infinitely many terms. So apply A by 1 minus R formula to get this sum. Now A value is, so first P of T into P of H whole square. Okay, this divide this with this. What is the common ratio? Students, otherwise you can take P of T into P of H whole square common. Otherwise directly you can do, no problem at all. So So here first term is P of t into P of h whole square by 1 minus this by this. So if you divide this by this, so P of t into P of h only will come. P of t into P of h. Now simplify. P of t is 2 by 3 and P of h whole square 1 by 9 whole by 1 minus, what about this? P of t 2 by 3 and P of h 1 by 3. Now in the numerator 2 by 27 whole by, in the down 7 by 9. 7 by 9. Now 2 by 27 into 9 by 7. So 9 ones are 9 threes are. Now 2 by 21 is the P of E2. But what you people have to find? P of E. Now P of E is equal to P of E1 plus P of E2. Now P of E1, how much have you got? 1 by 7. Now P of E2, 2 by 21. Now do this simplification whose LCM is 21. So here 3 plus 2 which is equal to 5 by 21. So that is your required probability which represents getting head at the end of the experiment. Thank you.